All right, in this example, we're taking a look at another infinite limit. In this case, the limit as x goes to infinity of the rational function minus 3x squared plus 2x minus 1 all over 6x squared minus 5x plus 2. All right, so just like before, what we're going to do is identify the highest power on top, which is a 2, right, over the highest power on the bottom, which is again a 2. And so what we're going to do is just factor out the highest power on top and bottom. And here I've omitted some of the steps where I divide and cancel, but that's exactly what I did. Negative 3x squared divided by x squared is negative 3. X divided by x squared will be 1 over x there, and so on. So if those steps confuse you a little bit, take a look at the previous examples, and you can see how that works. So, okay, and just keep going a little bit further here. This is just what I had, and if you notice, these x squared divided by x squared, right, they just cancel each other out. Cancel that out, and this is what I'm left with. And I have a negative 3. The limit as x goes to infinity of that is negative 3, and the limit as x goes to infinity of 6 would just be 6. And the rest of these are either exactly power functions like this or some number times a power function, right, where the x to the number power is in the bottom, and all of those go to 0. And in fact, right, all of this work would be exactly the same for the negative infinity. All of these go to 0 as x goes to infinity or minus infinity. And so what you wind up with is on top you'll just have a negative 3, right, because these all go to 0. Here you'll have just a 6, because all of those go to 0, right, and then reduce that down to negative 1/2. And so the limit as x goes to infinity of the function was negative 1/2, and the work is exactly the same as for the negative as x goes to negative infinity. It will be exactly the same. All of the work, the only difference you'll have as x goes to negative infinity, and all this analysis will be exactly the same. So it turns out that the limit as x goes to negative infinity of the rational function is also negative 1/2.